Remember, I'm not collecting your notebook, so whatever your notebook is, it is you. All right. So it's on 96, 97, 90 something.
Are these 3B.2?
It's 0.1 part B. So this is going to be your 3B.1 part B notes. No, this is just defining what an inverse means. So going back to Algebra 2, you learned that in first semester, you learned that in order for an inverse, for two functions to be inverses of each other, if you were to compose, Fogg and Goff, compose them of each other, then their output would always be X, okay? And so that's just reminding you the definition of a inverse function, okay? So down at the bottom are our properties for our inverse functions. So if you have sine and then you have sine inverse of X, it's going to equal X. And that's for every X in the following domains. And then vice versa. But these are the domain restrictions. If it's outside of these, then it is undefined, does not exist, not applicable.
Explain what this is calling.
Yes, I remember you guys said you don't mind me to talk while you're writing, so that's why I said I'm gonna give y'all a second to write. And then I'll... Am I good to talk? All right. So the first one we have sine inverse of X. And it's saying that if your X value falls in the interval between -1 and 1, the answer will just be whatever that X value is. Does that make sense? So for example, if this was sine inverse 1/2, I could use this and my output would be 1/2. Because 1/2 falls in the interval between -1 and 1. Does that make sense? Now, if it does not fall in between there, then you actually go through the motion, find the sine inverse, plug it in, and evaluate. Okay? These rules only apply if the given angle, theta, unknown, falls in between these intervals. Does that make sense?
So basically, it's like if we have an angle, say the angle is 5/6, and we find the inverse of sine, and then sine.
So it's saying pi/6. So pi/6 falls between -1 and 1, right? So pi/6 would fall between that interval. And because pi/6 falls in between that interval, that means that the answer is just pi/6. So
it'll be like probably they'll tell us the interval.
You have to know which interval is supposed to fall in between. Like the intervals are for you to know. They're not going to tell you this is your interval. You just know that this is the property. Based on this property, in order for it to be true and work, it applies to these intervals.
Which way do you go around the unit circle when like that? Like, would you go clockwise from the?
So it depends on which way you're going.
Like for this, how would you draw that on the unit circle? Like point out -1 to 1. Can you start at pi and then work your way down, or work your way up?
If anytime you're negative, you're going to be going clockwise. Okay, so yeah. Anytime you're going negative, you're going to be going clockwise. Anytime it's positive. So just think about like you're either, you can't do it from here, but this is here. So you're either going pew, or you're going pew.
Like if I asked you to like draw a unit circle and shade the domain for that,
you can't shade the domain. There's no shading of the domain for the unit circle. Yeah. That only applies for when you're actually graphing it on an XY plane.
Oh, okay.
All right, so let's apply it. Are you ready? So up first, we have sine inverse of sine 2 pi over 3. Okay, so that's our first example is sine inverse of sine 2 pi over 3. First, you're going to ask yourself, for this property to work, what interval must be true? So your interval in order for this to work is going to be negative pi over 2, 2, pi over 2. Do we see that? Yes. All right. Does 2 pi over 3 fall in that interval? No. So ask yourself, does x fall in between that interval? And the answer is no. When it doesn't fall in between that interval, that means you have to evaluate. So you're going to
Negative pi over 2, pi over 2 is like just the whole right side of the unit.
yes.
Okay.
Essentially. Yeah.
So how is 2 pi over 3?
It's not in that interval. Did we say it's not in that interval? That's
No,
what-
I thought we were supposed to be finding.
No, first you establish if it's in the interval or not. If it had been in the interval, like this, let's say this had sine of pi over 3, right? Pi over 3 is in that interval, correct? And so therefore, the answer is just pi over 3, and I don't have to do any extra work. Okay? But because it's not in that interval, there's extra work for me to do. Does that make sense? Okay? We didn't switch the interval. So what do we say the interval is if it's sine inverse of sine? You follow the direction. If it's hard for y'all to visualize it, think of it instead of the unit circle, just think about it being on a line, like on a graph. On a graph, you're going from negative pi over 2 to pi over 2. It's horizontal. Like, don't even think about it being on a unit circle. Do those follow your number line.
Do you understand that part? No, I think that and from here, going on the right side of the circle, and that's where our limit is versus going on the left.
It's going from negative. Oh, positive.
Yeah, that's what I'm saying. Don't think of it as a circle. Each section is a little bit different. I told you that's unit C. I already told y'all, we know that. Okay. All right. Anyways, does it fall? Yes or no? No, we agree that it doesn't. Because it doesn't fall in this interval, that means we have to evaluate it in parts. Okay. So we have to evaluate this in parts. So the first thing you're going to do is you do the innermost piece first. So my innermost is sine of 2 pi over 3. Sine of 2 pi over 3 equals what? Square root of 2 over, no, it doesn't. 3. I said, no, it doesn't. I corrected myself. I was like, wait, that is not a 45. All right. So we get square root of 3 over 2. So that means now, after we evaluate, we're now going to substitute that back in. So we're doing sine inverse of square root of 3 over 2. So we found what it equals, and we substituted it in. Just like any other time, you find y, you can plug it in, right? We found what it equals, and we substituted it in for the in. Yes? Now this goes back to what you did in part A. Is it not back to part A? It is. So therefore your theta equals what? Pi thirds or pi 6? Huh?
Yeah, where'd we get the why? Because it's 9 and square root of 3 1/2. So like, wouldn't pi 6 be sine of 1/2? Yes. The y value is 1/2.
Is it?
Yeah.
Yeah. Wait, what are we doing? The x value is square root of 3 over 2. Or
It's just there to the side of the.
That doesn't feel right. Look at your unit circle. Am I right there, right?
so I know for sure the x value.
It is 1/2.
Pi over 6.
Yes, yes.
So
It's
the y value would be. So like,
Pi.
so confusing.
Yeah, it is.
Okay. It's okay. Let's try again. I don't know.
That's a player.
What do you mean to do it the opposite way? We did it.
Like, we're fine now. No, why don't we do opposite?
What did we do yesterday? This is all step 2 is what you did on when? Is it not one?
I don't remember anything.
The sine,
To me.
if you go to pi over 6, what is the y value?
The y value is like half.
It's half, okay. At pi over 6?
The y value at pi over 6 is 1/2.
Okay, yeah. So it's 6. I 1, 2, 3, 1, 2, 3. Yes. That we're not. It's pi over 3. Well, the guys, I had a great bar. I know y'all. You're right. I wrote pi over 3.
Why does it feel like the opposite? No,
I just had
like,
a
inverse on
I mean, but I used today, I wasn't.
Hey guys, I'm sorry. I cannot. Okay, back. All right. We resolved. We're smart. We got it. So if you weren't part of our class, you don't know what happened, but we're good. All right. So cosine inverse of 3 pi over 4. The first thing you ask yourself is what is the interval that satisfies this rule, right? The interval is -1 to 1. If you look at your cosine inverse, it says -1 to 1. I'm assuming so, yes. Or just have a general idea of where your restrictions lie as a cosine function. Okay? All right. Does 3 pi over 4 fall on this interval?
Yes.
Are you sure? Are you sure?
Wait, no.
Are you sure?
3
3 pi over 4 does not, because think about it. What is pi numerically? What's the value of pi? 3.14. And what is 3 times 3 point? And then you divide. Does it fit in that interval? No, it does not. And because it doesn't fit in that interval, I'm gonna tell you. Yeah, I'll put it's not. Because you can't go any further. You can't identify an angle. So the difference here is that you're starting off looking for the angle. So this one, the cosine inverse tells me I'm looking for my angle.
Oh, it's opposite of
It's the opposite. This one, I already had my angle and I had to find a value and I can evaluate.
we're looking for the angle.
This one, the angle doesn't exist.
Yeah, so it's like not really.
So therefore it's undefined.
There's not a y like. There's not like an x value.
Exactly. There's nothing that's going to make that possible.
We couldn't put cosine of x because or like cosine of
So does this fit? No, it's not on my interval. Again, think about this. 3 times pi is roughly 9 and some change. 9 and some change divided by 4 is bigger than 1.
kind of negative square root over 2, but that's not like
It doesn't exist.
we can't like
Yeah.
That's not-
So no, and therefore this is undefined. Okay, that also goes back to thinking about your inverse functions that we drew. So when we did, can I go back to the inverse function real quick? So for cosine, remember for its inverse, it already had restrictions on it. And if any value was outside of this, it didn't work. It did not exist. So if I don't exist, I can't go any further. And that's keeping in mind what the cosine functions were. Okay? Yes? All right.
It's starting to click. It's starting
Okay?
to click.
All right, here we go. Now, what are my restrictions for, yes? It's not that it's not on the unit circle. It can be not on the unit circle as long as it falls in between those values.
Because if what's that -1 and then 3/4, that would give us the x value of that, which is negative square root of 2 over 2. But you can't have cosine of negative square root of 2 over 2 because that's negative square root of 2 over 2 is not an angle.
It's not an angle.
And when you're doing regular cosine, it has to be an angle. And that's not an angle.
And it's not.
This one you should because it adds up a circle.
That's why I've already said that
Yeah.
3 times. Don't think of it as a circle. Think of it as the function, the graph, x on the xy plane. Okay? All right. So again, here we go. Interval check. What is the interval for this rule? What is it? 0 to pi. We agree? We all see it? 0 to pi. So our interval is from 0 to pi. Okay? Does 7 pi over 6 fall in that interval? No, it does not. Okay? The difference between B and C is that I can evaluate cosine of 7 pi over 6. Does that make sense?
Yeah.
I cannot evaluate cosine inverse of 3
Any
pi.
of them that have like it's the regular cosine and then the negative.
You can evaluate.
If it's,
But the
well, I'm saying like,
inverse-
I'll be any of them that look like that where it's not the negative code, the negative. On the outside.
The inverse, yes,
And then if inside it's not the thing, then it's always gonna be undefined.
yes.
Okay.
If I cannot evaluate the inverse, I can't go any further. Does that make sense? Okay, so if I can't evaluate it, I can't go any further, so therefore it's undefined, okay? On this one, this is not in there, right? So this value does not fall in my interval, agreed? Okay, so we gotta go through the same steps that we did on example A. We're going to evaluate first. So we have cosine of 7 pi over 6 equals what? It's negative square root of 3. We're in the,
Yeah.
in the X. It's negative. We're in the third quadrant. Yeah. Okay, so we evaluate. After we evaluate, we then are going to substitute it back in. So now we're going to substitute. So now it becomes cos, now you'll have me say that, cosine of negative square root of 3 over 2. It is. I don't know what you're talking about. It's there. Now we're asking ourselves what cosine value, what theta, what angle gives us negative square root of 3 over 2. And how did you know that?
Because of restricted domain restriction.
So this is saying like where's X at?
Where is x? Negative square root of 3 over 2.
And then you.
And for code, exactly. And we only can be in quadrants 1 and 2 anyway. And is that satisfied in there? Yes.
Okay, it's starting to make sense. It's starting to make sense.
So our theta would equal 5 pi over 6. It's lot, it's foreign, it's a whole nother language, right? It is a language of its own. All right, well, ask me so I can know where I can clarify or where I need to fix. It's going to get better with practice. It is something that you can't just instantly look at and say, oh, I got this. It does require you to practice, look at other options because it can look different, right?
Okay,
I-
but anytime the cosine inverse is in the parentheses.
No,
No.
it's anytime it doesn't fit in that domain.
Cosine inverse is the parentheses and it doesn't fit in the domain, then you can find it.
Yeah, like so exactly. If this had said cosine inverse of 1/2,
You could,
I could go, right?
because that's in there.
That's in the inverse. That's in our interval. So therefore, well, we can evaluate and go from there. So this had said cosine inverse of 1/2, what would you tell me? So in quadrants 1 and 2, what angle gives me a what x value of 1/2?
It's pi over 3.
Pi over 3 at the top, right here. So then we now have cosine inverse of pi over 3. No, I'm sorry, cos of pi over 3. Now we're asking ourselves, what would it be? Then it comes back to what?
The X value.
Which is
of
what?
Pi over 3,
Which is what?
which is also 1/2.
That's why if it's
Oh,
in between that interval, then it's gonna be whatever it is. Okay.
It's starting to click.
If it falls in that interval, whatever is inside is automatically gonna be your output.
Okay, this is so confusing, but it's.
That makes it easier.
Okay? You can go through the process every single time, but what you're gonna notice is gonna happen in the end.
It's a pattern.
It's a pattern, and you're gonna come out to be itself every single time, as long as it falls on this interval.
Is there any sort of
Okay.
pattern of remembering the properties that we don't have to just like memorize them, we can like know it based on a pattern?
I would say, so like, for example, if you were given the values here, it would be looking at the domains of your inverses. So like, if this was on I would like to say they would give it to you on a calculator part, and if they gave it to you on a calculator part, I would just graph the inverse and check the domain of it.
Yeah.
And then therefore you'll have, you know what your restrictions are.
Okay.
Is what I would say to do, but
Like graph.
like graph,
sign,
literally.
parentheses, sign, like,
Yeah.
sign, and then you would see it. Okay. Oh, graph it.
Yeah.
How do you
How do what?
do examples of that? Like tangent and stuff?
Can we do?
No, we had more, just graph. Yeah. I think I don't have a 10 one.
Oh, no. Tangent is confusing.
I don't think it's gonna be, I don't think it will be, because it said sine and cosine as the objective, like for the pre-cal objective for the property, it made it seem like it was focused on sine and cosine.
Wait, how
Yes.
do you do number 2?
Okay, so number 10, cosine inverse. So we have cosine inverse of 5/13. So you're asking what angles makes 5/13? Is that on our unit circle?
No.
No, it is not. However,
We know
We
that
have-
it's a real value. like,
it's a real value. It's something that exists.
It's less than half.
It's less, it works. It falls on our interval.
Yeah.
And you would be using your R cosine. Do y'all remember those rules? The theta
Yeah.
equals R cosine,
Yeah.
theta and,
What? That thing we did.
X
was
and
like,
Y?
Oh, yeah.
okay. So
It's
that's
like
what we're
sine of
doing.
theta is
It's
like
like one
y
of the
over
first
r.
three.
That's it.
It's fine.
Oh, y over hypotenuse?
So yes, going back to our original stuff. So for example, first off, we would do cosine theta equals 5/13, right?
Yeah.
And so that's how you would start creating, and then we'll keep going from there,
Wait,
but
how do we know what our interval is here? Because these are combinations, not part of the property. Did you say that already?
they are still part of it. Well, no, these are done. You're just now focused on, does it work for sine inverse? Does it
Oh,
work
okay.
for cosine?
We're not looking at the properties and looking at the like interval that has to be.
No.
Okay.
You're saying, does this work for sine inverse? Sine inverse properties are from -1 to 1, right?
Yeah.
What we did yesterday.
Wait, so cosine -1 of 5/13 equals 5/13.
Yeah, well, you have to find you need to find your y. Remember, we gotta find our y first, which is what? The factor triple, so what's the y there?
Your sine.
What is our y value?
Your
First,
sine.
if I have 5 and 13,
She's asking what.
what is my missing side?
Oh,
Your
Pythagorean
cosine,
triple.
your xi is missing.
But it was 12.
Oh,
Anytime you have 5 and 13, your missing side is
I know, but I do not know. Pythagorean.
like 3, 4, 5 go together, right? 3, 4, 5.
Oh, really?
Always the right triangle.
No.
You gotta do your 8 circles.
We never were told to the rest.
I just thought you were doing the pattern by the way.
Oh, no, we're stupid.
You're not stupid. I just thought you wanted to say, oh, we're using the same numbers over and over.
You're doing the wrong.
I'm gonna
stats.
keep doing the
Yeah,
factor
I
zero.
was like, out of that. 3, 4, 5. I didn't know this. I thought we were doing a whole new.
All right, on the first one, we're gonna start from the inside. What is I want you to start, number 9.
What is the angle words next?
So talk about it up, exactly. So what? Go for it.
Words -half is gonna be. Yeah.
Or
No,
What?
it's
negative.
4/3, isn't it?
I have to be in either quadrant 1 or quadrant 4, right inverse. Huh?
Wait, -6. No, because we have to be in quadrant 4. You can't go around.
Either going up.
Yeah.
Yes.
Yeah.
Yeah.
Wait, for this one, no, it's gonna be
What?
No, you're
what
right,
is
it's negative
it?
5. It's negative 5. Why 5?
Jump.
But it is. That would be. 6.
Yeah.
The y value. Yeah.
Okay, got it.
Negative
You'll be negative. All right.
Was it negative 5/6?
It would be negative. Yes, yes. So this right here is where you're at, right? So there. Yeah.
This is
The ones that
so
go
hard.
together. All right,
Okay,
we're gonna draw it out. Can we draw it out and just double check?
Yeah.
All right.
So now we're just doing cosine of pi/6, right?
Keep going back there because I keep leaving my pen back there. I drink my green.
Right, now we're just doing cosine of pi/6.
Yes.
Okay.
Negative pi/6.
What do you know about that?
Let's try this. So if you forget the unit circle, you can always. If you forget your unit circles, you can always revert back to just the basic of how to find anything. So if I have -1/2 for sine, that means it's my what and what? My y and my r, right? Sine is your y over your r. So I know that I'm here. And I know that this is -1, this is 2, and Pythagorean theorem tells me this has to be what? What's 4 minus 1? Square root of 3. Does that make sense? It's always y, that never changes. Your trig ratios never change. Yes, so I wanted to show you this. If you forget the unit circle, you can always go back to just drawing your triangles where they are. Okay? So if I'm in here, could I identify the angle? Yes. Okay, so if I'm looking here, it would be pi/6 because I know I have to be in this quadrant. And I know that I'm looking at when I get, because for sine inverse, it's between, it's the same thing, but it's its negative value that falls in between the interval.
Sine inverse, why do you not switch it to be like, 1 is your radius? Cause I know it's y over r, but if it's sine inverse, you're like switching.
That's a reciprocal, not an inverse.
That's the same thing as 1 over sine.
You're saying y over r, right? Switching it to r over y? That's reciprocating. That's secant. That's
But that's also
cosecant.
putting them both -1. That would, it's the same thing.
so your inverse is you like,
Well, like sine, the reciprocal of sine is inverse.
no, the reciprocal of sine is cosecant.
Wait, why is the reciprocal of sine not 1 over sine?
That's cosecant.
That's also sine inverse.
This sine inverse is not your reciprocal.
Sine is the -1.
It's
That's
inverse.
not over sine though.
Sine, this right here is called its inverse. This right here is called its reciprocal. They are not the same.
Sine -1 and sine 1 is just 1 over sine to the -1.
No, that's you're applying the exponent rule, and exponent rules do not apply to sine, cosine, and tangent.
Oh,
It's not the same.
none of it would apply to sine.
No, your exponent rule does not apply to that's not what a -1 means. When you're doing sine, cosine, and tangent, it means this is your inverse function. It's saying, here's your ratio.
Like it's like a no.
Yeah. I'm finding the inverse. I'm looking for the angle. I'm not looking for the ratio.